Okay. And I'm going to give you a few minutes to try and do these few problems. Hopefully some more people will show up. If not, all right, I think we should get started on these. And again, there are not so many people here today, so if you want to open up your either your video or your unmute yourself, that will be perfectly fine. If you have anything that you'd like to say or ask, just pipe up. Okay, so questions 1 and 2 are what we call systems of equations. And let's just go through, we want to solve both of these. So let's start with this one. When we have the x's, the y's, the equal signs, and the numbers all lined up, that is usually a good setup for what we call the elimination or addition method. And what we're going to do is decide, let's get rid of either the x's or the y's. Anybody have any suggestions? Should we get rid of the x's or should we get rid of the y's? Okay, since I have no suggestions, I'm going to decide I want to get rid of the y's, and it doesn't matter which I decide. But if I want to get rid of the y's, then I'm going to have to remember multiply by the opposite coefficient. So the top one I'm going to multiply by 4. And the bottom one I'm going to multiply by the 3. Now, remember, before I do anything, I just look at the numbers. It's not going to help. Clearly, let's see if I can do better. In terms of whether I should use a positive or negative sign, the first thing I just use is irregular numbers. Then I go back and I look at the signs. I need one of them to be positive and one of them to be negative so that when I add them, they'll cancel each other out. I already have that these are opposite signs, so I don't want to change the signs at all. So I'm just using the positive 4 and the positive 3. So the positive 4 will give us, when we multiply the top by 4 will give us 16x minus 12y equals 4 times 19, which is 76. And of course, you could use a calculator when you're doing this. So you could just multiply the 4 times the 19. The second equation, you're multiplying through by 3. So you're going to get 15x plus 12y equals negative 45. And now when you add these two equations together, the 16x plus the 15x will give you 31x. The negative 12y and the positive 12y will cancel out. That's, we said we wanted to eliminate one of the unknowns, and we decided it was the y's that we were getting rid of. And when we add 76 plus 45, we get 31. And now to figure out what x is, we just divide by 31 on both sides. And of course, that gives us x equal to 1. Once we have what the x is equal to, we can take either one of the equations and replace the x with the 1. So let's try that first equation. So we'll do 4 times 1 minus 3y equals 19. This will be 4 minus 3y equals 19. Bringing the 4 to the other side. We'll end up with negative 3y equals 19 minus 4, which is 15. And when I divide by negative 3, I get y equals negative 5. So my solution is x is 1 and y equals negative 5. You could either leave it like that, or you could write it as an order pair, 1, negative 5, remembering always that the first number is the x and the second number is the y. And that's how we solve an equation using the elimination method. Any question about this? Okay, so then let's look at the second question over here, which is again a system of equations. But here we have the first equation in standard form, the y's, the x's, then the equals. But the second equation is given x equals 1 minus 3y. And I have two choices then. If I want to use the elimination method, the addition method, I'm going to have to get the x's and y's on one side and the numbers on the other side on the second equation. Alternatively, since this says specifically x equals 1 minus 3y, I can use the substitution method over here. And it's sort of set up perfectly for the substitution method. So I'm going to use substitution on this one. Again, even if it tells you to do elimination or substitution, whichever method, remember this is the midterm is a multiple choice test. So all you have to do is pick the right answer. So nobody's going to be checking to see what method you've used. We're going to be checking if you got the right answers. So if you get it, so if you prefer doing the elimination method, go ahead and do it. As I said, I'm going to use the substitution. And in my first equation, I'm going to write my 6y plus 2. In place of the x, I'm going to put the 1 minus 3y. And that's going to be equal to 2. And now I just have an equation that has only y's in it. So I can just solve it the way we've already solved linear equations. I'll remove the parentheses. 6y plus 2 minus 6y equals 2. And when I combine the like terms on this first equation, on this equation, I have a 6y and a negative 6y that cancels out. And I'm left with no y's. I'm left with the equation 2 equals 2. And here's where we have to make a decision. If when you have a system of equations or any equation that you're solving, and when you do the solution, all your variables drop out, not just one of the variables, not just the x's or not just the y's, but both the x's and the y's. There's two things that can happen. Either you can have no solution, is one possibility, or all real numbers, everything. So it's either going to be number 1 or number 2. The question is, how do I know, does it have no solution or does it have every single number as a solution for what we call an infinite number of solutions? So we look at what we get after we've gotten rid of all our variables. In this case, we're getting 2 equals 2, which is a true statement. If we get a true statement, then my answer is going to be an infinite number of solutions. I can pick any number I want for x, and or in this case for y. I can pick any number I want for y. My x will be 1 minus 3 times that number, and that solution will work. When do we get no solution? Let's say this had turned out to be 2 equals 0 or 7 equals 1. 2 different numbers on the equal side that are not equal. This happens to have been a true statement. So therefore, we had infinite solution. If I would have gotten something like 2 equals 0, this would have been false. If that's the case, there would be no solution, and we would write either no solution or we could write this 0 with a line through it. So in most cases, when we're solving a system equation, we're going to get one solution. When I mean one solution, a one value for X, one value for Y. It's going to be two numbers, but it's one solution. The solution is X equals 1, Y equals -5. But if all the variables drop out, then we're going to have either the case where there's no solutions, that's the case where everything drops out and you get a false statement, two numbers that are not equal. Then you get no solution. But if you get the two numbers being equal, which is we did in this case, a true statement, then there's an infinite number of solutions. Okay. That is systems of equations. So now let's just do this one. I'm getting a little messy, so I'm going to erase a lot of this stuff. Now you can see it better. If there are no questions, then I'm going to go on to that last question, which is to factor this completely. So let me erase what's over here. And we will do that third question. And it says to factor this completely, 64 x squared minus 60. Let's remember when we want to factor that the first thing we always look for is the greatest common factor. That's always step number one. Step number two depends on how many terms you're left with. If you have two terms, you look for the difference of squares. If you have three terms, then you go to your trinomial factoring. And if you have four terms, then you go to grouping. But the first thing always is to look for greatest common factor. And I look at the 64 and the 16, and the 16 is a common factor. It goes into both of those numbers. So the first thing I'm going to do is I'm going to put the 16 on the outside. 16 into 64 is 4, so this becomes 4x squared. And 16 into 16 is 1. Don't forget to put in the 1. It doesn't disappear. When you do 16 divided by 16, you get 1. So that's our first step. Our second step is to decide, do we have 2 terms, 3 terms, or 4 terms? Obviously, we have 2 terms. So we look, is this the difference of squares? Well, this is a perfect square. It's 2x times 2x. And 1 is also a perfect square because it's 1 times 1. So we can factor that further. If it's not the difference of squares, we can't go any further. But we can, and we're going to put the 2x in the front of each parenthesis, and the 1 as the second in both parentheses. And in one parenthesis, we'll put a 1, and one parenthesis we'll put a, in one parenthesis we'll put a plus, and the other one we'll put a minus. So that we get what are called conjugate binomials, identical binomials, except one with a plus and one with a minus. But don't first say, oh, this is a difference of squares, and right away break it up into 2 parentheses. The first thing is to take out the common factor. Okay. I'm just going to put two more problems on the board and give you a few minutes to try them. While you're doing that, I will take attendance. And then after that, if nobody has any questions, we'll go on to some new material. So first of all, I just want you to do it says perform the indicated operations, okay? So the first one is negative 4x to the third minus 6x squared minus 2x plus 10 minus negative 5x cubed plus 5x squared plus 6x minus 10. Let's see if you can combine those two polynomials. They're each what we call 4 terms. We want to combine all the like terms. And the second one I'd like you to do is I'd like you to multiply 2y plus 4 times 3y squared minus 4y plus 5. Those are two polynomial examples. One's a subtraction example and one's a multiplication example. Okay, listen for your name when I take attendance. Olivia. Isis.
Here.
Are you here, Isis?
Yes, I'm here.
Found it low. Your thing was low. Have a good to have you here. Alvaro. Lewis Hart. Emma.
I'm here. Good morning.
Good morning. Demetrius. Desmond. Shania. Ricardo.
I'm here. I'm sorry. I'm here.
Shania, that
Shania. Yes, I'm here.
Good morning.
Good morning.
Thanks for signing in. Kayla, I know you're here, Kayla. You were number 1. Sanjita. Sanjita here. Ariana. Tahira.
I'm here.
Hi, good morning. Michaela. Kiana.
Here.
Hi, good morning. Carly. Jen. Hi, good morning. Jenna. Tatiana. Naya. Kazandu. Trina. Jean. Missing somebody. Judah. Okay, I think we can get started on these. First of all, when I have two polynomials that I either want to add or subtract, first, I want to first remove the parentheses. And if there's no number in front of a parentheses, it's understood that there's going to be a 1 there. It's a 1, and just like in front of a variable, if you just put the variable x, it really means 1x. Same thing with any parentheses. If there's no number in front of it, it's really understood as if there's a 1. So the first parentheses will just multiply everything by +1, which means don't change anything and just leave it -4x to the third minus 6x squared minus 2x plus 10. In front of my second parentheses, there is now a -1. Don't forget there was this negative before, so I'm going to have to multiply everything in that parentheses by -1, which is going to give me plus 5x to the third. And -1 times positive 5x squared is going to give me -5x squared. -1 times 6x is going to give me -6x. And -1 times -10 is going to give me +10. Basically, when you have a minus in front of a parentheses, it really changes the signs of every single term in the parentheses. And now we're going to combine the like terms. So there's a -4x to the third, which I can add with a +5. So -4 plus +5x third is going to give me 1x to the third, or just plain x to the third. The x squareds are the -6x squared and the -5x squared. So -6 plus -5 gives me -11x squared. And you could do this on your calculator, not the x parts, but you could certainly do the number parts by doing -6 minus 5. It'll give you the -11. Then we have -2x and -6x, which together combine to -8x. And finally, +10 plus 10 gives me +20. And there are no other like terms, so this would be my answer, x to the third minus 11x squared minus 8x plus 20. Just be careful with your signs. Be careful when you're adding, subtracting numbers that you're doing it correctly. Again, you're allowed to use a calculator. So if your calculator helps you get the right answers with the sign numbers, make sure to use it. Be very mindful of the positive and negative signs. Okay, the second one is a multiplication. We have a binomial, 2y plus 4, times a trinomial, 3y squared minus 4y plus 5. Now, we can't use FOIL on here because FOIL specifically means when you have two terms, a binomial times a binomial, two terms times two terms. But what we do is we just use the distributive property twice. We're going to take first our 2y and multiply everything in the parentheses by the 2y. Then we'll go back and multiply everything by the 4. And after we've done all the multiplications, we're going to look if there's any like terms that we can combine. So multiplying the 2y by this parentheses, 2y times 3y squared is 6y to the third. Remember, you add those exponents. And this is an exponent of 1. Then we have 2y times negative 4y, which is negative or minus 8y squared. And then we have the 2y times 5, which gives us 10y. Now we're going back. We're multiplying everything by 4. 4 times 3y squared is 12y squared. 4 times negative 4y is negative 16y. And 4 times 5 is plus 20. Okay, so there's no other y cubed, so we just bring down the 6y cubed. We have a negative 8y squared and a positive 12y squared. Those are like terms. So we add negative 8 plus 12, which gives us positive 4y squared. We have a 10y minus a 16y. Those are like terms. 10 minus 16 is negative 6. So we get negative 6y. And we just bring the 20 over because there's nothing to combine it with. There's no more like terms. This would be my answer to that question. I hope most of you got that right. Does anybody, you can just write it on the chat, does anybody have a particular topic they'd like me to review before the midterm is posted? Any particular type of example? Okay. I see, Jenna, you joined us. I'm putting you down. Okay. Let me see. I noticed that only a couple of people have done the midterm preview test. Now I'm leaving that posted. It is a requirement. It's not just a practice. Let's just practice. It happens to be a requirement. It is what you get. You will get a test mark for it. As I said, you have two chances to do that midterm preview. Make sure you get that done. Also, and this is of extreme importance, the midterm will be posted on Blackboard starting at 10 o'clock this morning. It will be posted until the end of the day on Monday, October 31st. Make sure you get it done in that time frame. If you can't, let me know so I can extend the time for you. You must do, these are tests that are required you're not passing the course if you're not doing the tests and the homework. I have not added any new homeworks. I'm going to start after the midterm. I'm going to be adding new homeworks again on Delta Math, but I wanted you to concentrate on the previous homework so that you're prepared for the midterm. After I get the midterm grades, probably sometime at the end of next week or the beginning of the following week, I will be sending out a individual email to each one of you telling you how you are doing in the class at this point. In other words, it won't be a specific grade. I might give you an average because obviously I can't give you a grade that is not going to be appropriate in 2 weeks, but I'll give you an idea of where you stand in the class as of next week. And if you're missing any work, what your work is missing and how it can affect your grade. Now, if you're missing, or if you haven't done the quizzes on Delta Math, and if you haven't done the homeworks, now, when it comes to I give you a homework mark, if based on most of the homeworks being done, if 1 or 2 homeworks have not been done, I will not reduce your homework mark, but the homework is just an indication. Did you do the homework? It doesn't have to be a good mark or a bad mark. The mark on the homework is immaterial. What it has to be is done. So make sure you do the homework so you can get all the credits. There, I think 10% of your grade, your final grade, is based on just doing homework. So make sure you get those points for doing the homework. Okay, starting next week again, I'm going to also be continuing our extra credits for people who post answers on the chat or who actually come tell them in person. Those extra credits are going to be helpful. Let's say your final average turns out to be 78. Now 78 is really a C. It's a C plus, but it's a C. But if you would get 2 more points, you would then be in the B range. Those extra credits can help you boost your marks so that you go from 1 grade range into a higher one. So make sure you do your homework and make sure when you're in class to get involved in the class, because class participation, which I get by I have it written down, by writing down who's sent in an answer, who's made asked a question, who's done something. If you have done that class participation is included in your final grade. It's not just the mark on the midterm and the final. The midterm and the final together is only about 65% of your grade. 35% of your final grade comes from classwork, homeworks, quizzes, etc. Okay, let's continue from here. We talked about multiplying and dividing of rational expressions, fractions. Now we want to go on to adding and subtracting. Let's just do one more problem before we say we're finished. Let's say I gave you this, 2x minus 3 over x squared minus 10x plus 25 times x squared minus 25 over 10x minus 15. This is a review of what we had started doing on chapter 5. This is called multiplying rational expressions. If you recall what I said, when you're multiplying and dividing, it's almost the same thing. The only difference between the multiplying and the dividing is if this is a division sign, your first step is to take the reciprocal of the second fraction, which means flip it over, and then do the multiplication. So this is a regular multiplication. I don't have to take the reciprocal. I just have to do the multiplication. And if we recall what we said was the first thing we're going to do is we're going to factor everything as much as we possibly can. Okay, let me just say, when it's division, then you have to do the reciprocal. And then if it's multiplication or division, after you've done that reciprocal, if it needs to be done, the first thing you're going to do is take each one of your pieces of your fractions and factor them as much as possible. So let's look at this. This is 2x minus 3. There's no common factor. I can't factor it any further. I just leave it alone. Then I go to the denominator of that fraction, x squared minus 10x plus 25. And I see this is a trinomial, so I know I'm going to have to do trinomial factoring. And since my leading factor, my leading coefficient happens to be 1, I can right away break it up into the two parentheses. And I look at the x squared, I break up into x and x. Then since I see my last term is positive, it means both signs are going to have to be the same sign. The middle sign is negative, means these are both going to be negatives. And we're looking for numbers that multiply to 25, but when we add them, we get 10. Obviously, that's 5 and 5. I could have written this as x minus 5 with a square on the outside. This x squared minus 10x plus 25 is a binomial square. It is the two binomials you get are identical. You could write it with just a square on the outside. I actually prefer to write it as two separate ones because I want to now, after I do all the factoring, see if I can cancel things out. So it's easier just to keep track of how many you have there. Okay, let's go to the next fraction. My numerator is x squared minus 25. Now, again, we look for a common factor, which there isn't any, but we see this is what we call the difference of squares. So again, we could break it up into our two parentheses, x and x, and it's going to be 5 and 5, but one's going to be a plus and one's going to be a minus. Notice they're not both minuses, they're not both plus. There's one plus and one minus, what we call conjugate binomials, looking the same except with opposite signs. And finally, I look at this 10x minus 15, that second denominator, and I do see that there's a common factor. Between 10 and 15, we can put out the 5 on the outside. 5 into 10x is 2x. 5 into negative 15 is negative 3. Okay, so that's step number 1. What's step number 2? we cross cancel. We start at the top of our first fraction. And remember, these are binomials, so they have to be canceled out. The whole binomial with the whole binomial. So this is a 2x minus 3. I'm looking to see, is there another 2x minus 3? And yes, there is in the denominator. I can only cancel out a numerator with a denominator, and it has to be the identical binomial. We can't do it by pieces. You have to take the whole unit, the whole binomial. So this 2x minus 3 is going to cancel out with this 2x minus 3. Now over here, I can't cancel out everything, so I put a 1 there just to remind myself that I canceled out by division, and what I'm left with is not a 0. I'm not left with nothing. I'm left with a 1. I go then to my next term, the next binomial that I'm looking at, and it's x plus 5. Is there any x plus 5 that I could cancel out with? And the answer is no. I can't cancel out an x plus 5 with an x minus 5. I can only cancel out an x plus 5 with an x plus 5. So there's nothing to cancel out that x plus 5 with. I then go to this x minus 5, and I can cancel that out with one of these. It doesn't matter which one or the other. And now, let's see, I've canceled everything that I can possibly cancel out. So now I can finish the example by multiplying the numerators together and then the denominators together. I don't cross multiply. I multiply the numerators. So the first numerator is 1 times x plus 5, which gives me x plus 5. That's the numerators, and the denominator is x minus 5 times 5, which I could write in it, leave it in its factored form, leaving the 5 and the x minus 5. That is one way of writing the answer. Or I could write the answer as x plus 5, and I could multiply using the distributive property, write the denominator as 5x minus 25. Both of these answers are completely correct. If you were doing a multiple choice question, it would either give you this answer or this answer. It can't give you both because they are both equally correct. This is not going to be on our midterm. This is on towards the final. Let's do one more question like this. Okay, let's take this question. I have 5x minus 10 over 6x minus 9 divided by 6 minus 3x over 8x minus 12. And this one happens to be a division example, not a multiplication. But let's see if we could do this. Okay, remember what we said. The first thing we're going to do is look whether it's a multiplication or a division. This is division, which tells us my first step is to take the reciprocal of that second fraction. So I'm going to rewrite this as 5x minus 10 over 6x minus 9. I leave the first fraction alone. Change the division to a multiplication problem and take the reciprocal of the second fraction. In other words, put the 8x minus 12 on top and the 6 minus 3x on the bottom. Okay, that was step one, and that was, we've taken care of it. We're now dealing with a multiplication example. So we know the first thing we have to do is factor. Factor each of the numerators and denominators totally. Now, these are all going to be common factors. In the first one, we have a common factor of 5. 5 goes into 5 into 10. So we're going to put 5 over x times x minus 2. In the denominator of that fraction, we have a 6 and a 9 as our coefficients. We can take out a 3, and it'll be 2x minus 3. Now we have 8x minus 12, and that has a common factor of 4. So we're going to get 2x minus 3. And finally, over here, in 6 minus 3x, my common factor is 3. So we're going to get 2 minus x. Okay, so we've done all the factoring. We're now at what we call the cross canceling or the cross reducing part. And I right away see that I have a 2x minus 3 over here that can cancel out with a 2x minus 3. Now the numbers on the outside, the 5, the 3, the 4, and the 3, there's nothing I can do with it because the 2 3s are both out on the bottom, so I can't cancel out a denominator with a denominator. And 5 doesn't cancel with 3, and neither does 4. The only thing that we have to consider is this x minus 2 and this 2 minus x. If you notice, I've been saying all along that the only thing you can cancel out are identical binomials. When it comes to polynomials, they have to be identical. They can't be x minus 2 and x plus 2. They're not exactly the same. It can't be 2x minus 3 and x minus 3. The binomial has to be, it's a unit, it has to be identical. There's one slight exception to that rule, and that has to do with binomials that really are identical except their order has been switched. For example, I could have on a top an x plus 5, and on the bottom I could have a 5 plus x. Now you and I know that x plus 5 and 5 plus x, even though they don't look identical, they are really identical. Because when you change the order when you're adding, it doesn't make a difference. X plus 5 can cancel with 5 plus x because they are identical binomials. So it seems that when we have binomials where the order has been switched, we could also cancel it out. If we have an x plus 5 and a 5 plus x, we can totally cancel it out. Those are considered identical. Well, we have a similar case here where we have an x minus 2 and a 2 minus x. these two binomials have the exact same numbers in them. The only thing is they've been switched. Their order has been switched. Are they the same thing? Well, let's think about it. If I do 7 minus 5, is that going to be the same as 5 minus 7? If we subtracting and we change the order in which we subtracting, will we get the same answer? And the answer is obviously no. You can't just switch when you're subtracting. When you're adding, we call it the commutative property, it doesn't make a difference. But if you're subtracting, it certainly does. If I do 7 minus 5, I'm going to get positive 2. And if I do 5 minus 7, I'm going to get negative 2. Notice what happens. I get the same number, but the order is, the sign is switched. In one, I get a positive 2, and the other, I get a negative 2. Anytime I change the order in which I'm subtracting, if I go from 9 minus 13, I'll get negative 4. Whereas if I'll do 13 minus 9, I'll get positive 4. The number will be the same. The only difference will be that there'll be a difference in sign. One will be positive and one will be negative. So if I have an x minus 2 and a 2 minus x, those two are really the same number, except one is a positive number and one is a negative number, which means that we can cancel these out with each other, except that I must put a negative 1 in place of one of them, because they're the same number. It's like I'm dividing a negative 4 by a 4 will give me a negative 1. I'm dividing a 2 by a negative 2, I'm getting negative 1. So whenever I have these binomials in the opposite order and the sign is minus, you can cancel them out as long as you put a negative 1 in place of one of them. And I always put the negative in the numerator because I want to be consistent. Doesn't matter if you put in the numerator or the denominator, but it's really better in the numerator in terms of the format, which means that in this case, the answer becomes, now I'm finishing this up, 5 times negative 1, which is negative 5. This is not 5 minus 1, it's 5 times, this is in the parentheses. 5 times negative 1 is negative 5. Negative 5 times 4 is negative 20 in the numerator. And in the denominator, it's 3 times 3, which is 9. And that's the answer to this particular example. Notice we were able to cancel out even the x minus 2 with the 2 minus x, even though we're identical, because the only thing that was done is that the order was switched. Again, if the order is switched and it's a plus, it's totally the same, you just cancel it out. If the order is switched with a minus, you have to put a minus 1 in place of one of those parentheses. Okay, let's just get started on the next topic, which is adding and subtracting of fractions. And just like I did with the multiplying and dividing, where I demonstrated with just plain numbers, I'm going to do that with adding and subtracting. What's interesting is usually when we're talking about doing the operations like adding, subtracting, multiplying, and dividing, we first add and subtract, and then we multiply and divide. The reason we did with fraction, the order, opposite order, was simply because adding and subtracting a fraction is harder than multiplying and dividing. So let's now talk about how do we add and subtract fractions. So number one, we could have something like this, 5/7 minus 3/7. The rules for adding and subtracting are basically the same. You can add and subtract fractions as long as they have something called an LCD, a lowest common denominator. The important thing is a common denominator. Both the fractions have to have the same denominator. If you notice here, I have 5/7 minus 3/7. They both have denominators of 7. They have a common denominator. Then what you do is you just combine the numerators. In other words, you do the 5 minus the 3, which is 2, and you put it over the common denominator, and your answer would be 2/7. Again, as soon as your denominators are the same, you forget about the denominators, you just work with the numerators or the tops, and whatever answer you get, you put it over the common denominator as your final answer. So if I were to give you an example that looks like this. X over x squared minus 1 plus 1 over x squared minus 1. Let's say you have, now we're already dealing with rational expressions. Suppose I have these two fractions that I want to add. So just like I did before, I want to see, do I have a common denominator? And yes, I do. My common denominator, they both have an x squared minus 1 as their denominator. So remember what I said to do. Just take the numerators, the x plus the 1, combine the numerators, and put it over the common denominator x squared minus 1. So once you have the same denominator in both, just work with the numerators and combine any like terms. In this case, there were no like terms. And we're left with the x plus 1 over the x minus squared minus 1. What you then have to do is see if you can simplify the fractions. Remember how to reduce fractions. We look to see if we can factor anything and cancel out a common factor. So first we have to combine the numerators, put them over the common denominator, and then see if we could simplify our fractions. Now in this case, the x squared minus 1 can be factored into x plus 1 and x minus 1. Remember, when you want to simplify or reduce fractions, you have to factor as much as you possibly can. Notice we have a common factor of x plus 1 in the numerator and the denominator. We can cancel it out. Don't think we can cancel out the x plus 1 with the x minus 1. The only thing we can cancel out the x plus 1 with is another x plus 1, or possibly a 1 plus x if the order was in a different order. Remember, this is totally cancel out. We put a 1, and my final answer becomes 1 over x minus 1. Don't forget that the 1 is on top. Don't write your answer as x minus 1, because that x minus 1 is in the denominator. That's why it's important when something is totally canceled out to put a 1 in place of it. Okay, let's try another example. Suppose I have 2x minus 5 over x minus 2 minus x minus 3 over x minus 2. Okay, again, we have a common denominator. Our denominators are both x minus 2, which means now we're just going to be working with the numerators. We're going to take the 2x minus 5 and subtract. Now notice I have to put it in parentheses, the whole x minus 3. Because this minus is in front of the whole fraction, it has to be, when we do the subtraction, we're going to have to subtract the whole x minus 3. Now this is all going to be over x minus 2. And the first thing we're going to do is simplify the numerator by combining the like terms. Don't forget, when you have a minus in front of a parenthesis, if it's a minus 1. So what we really have is 2x minus 5 minus 1x plus 3. Don't forget, we're multiplying, we're distributing this negative 1, which I'm going to combine. 2x minus 1x is x. Negative 5 plus 3 is negative 2. Don't forget to put it over the common denominator, which is x minus 2. Notice after we've combined the like terms and put it over the common denominator, we have the x minus 2 over x minus 2. These are identical binomials. They can be canceled out. And my final answer is 1 over 1, which means my answer is just 1. Okay, I'm going to give you one to try. Remember, and again, we're still doing examples that have a common denominator. Okay. I'm going to give you a couple minutes to try this one out. 4 over y minus 4 minus y over y minus 4. See if you could simplify this. So combine the like terms and get your answer in simplest form. Okay, let's work on this together. It's really not so hard because we already have a common denominator of y minus 4. So all I have to do is the numerators, the 4 minus the y. And that's 4 minus y over y minus 4. And now we just want to see, can we reduce this? And these two binomials, this y minus 4 and this y minus 4 and this 4 minus 5, are actually identical except for their order. The order has been switched. This has the 4 first and the y second. This has the y first, the 4 second. But there is a minus in between them. Remember, we said we can cancel them out as long as we put a -1 in place of it. We can, when there's a plus and the order is changed, just cancel it out like regular. But if there's a minus and the order is changed, put a -1 in place of 1 and a 1 in place of the other. We're getting -1 over 1, which is just equal to -1. My answer in this case is -1. So let's see what happens if we do not have like denominators. What if we don't have a common denominator? We can only add and subtract fractions if they have the same common denominator. So what do we do if we're given a problem like this? I'm just going to deal with, first let's look at just, I'm going to remind you how we did this in elementary school, and then we'll do a couple of examples with variables as well, with rational expressions. But let's first talk about, what if I gave you 5 over 6 minus 7 over 8? And I said I wanted you to combine these two fractions. I want you to get these two fractions into a single fraction. And what happened, we can't just combine the numerators because the denominators are not the same. So what we have to do is find the least common denominator. Now, one of the ways we find the least common denominator is by looking at the larger denominator and then just see if the second denominator divides evenly into it. If not, just keep multiplying that number by increasingly bigger numbers. In other words, 6 does not go into 8. So the next thing I'm going to try is 16. 2 times 8 is 16. But 6 does not go into 16. So then I do 8 times 3, which is 24. And 24 is a good choice because both 6 divides evenly into 24 and 8 divides evenly into 24. So the first thing is, and sometimes we can do it just by basically inspection, just trying numbers, especially if all you have are numbers. Once you figure out what the common denominator is, you're going to have to rewrite. So number one, figure out what the least common denominator is. And then the next thing is to rewrite your fractions with that common denominator as each of its denominators. Now, obviously, if I'm going to change the 6 denominator to a 24, I've done something. Whatever I've done to the denominator, I've got to do to the numerator. So what do? I divide the original denominator into the new denominator. I'm going to put the number over here. 6 divided into 24 is 4. I take that number and multiply the numerator by it. 4 times 5 is 20. In other words, I changed the fraction 5/6 to its equivalent 20/24. We're doing just the opposite of what we started with fractions. Usually we start with a fraction like this and try to reduce it. Now we're doing just the opposite. We're starting with a reduced fraction, but then trying to get two fractions that have the same denominator. Once we did that with the first fraction, we do the same thing with the second. We divide the 8 into the 24, that gives me 3. I take that 3 and multiply it by the numerator over here. 3 times 7 is 21. So I have now renamed, I should call this rename rather than rewrite. I have now renamed each of my fractions so that they have the same common denominator. And once I've done that, I just have to combine the numerators and put it over the common denominator. So then I'm going to do 20 minus 21, which gives me -1. And my answer is going to be -1/24. Don't forget to put it over the common denominator. So we have to find the LCD. We have to rename our fractions so they each have that common denominator. And then we go ahead and proceed like we did before, combining the numerators. Okay, let's try this where we have some variables. So let's say I had 3x over 4 minus 7x over 3. Let's say I wanted to combine these two fractions. Again, when it's fractions, we first look at the denominators and we try and find our least common denominator. And since my larger denominator is 4, 4 times 3 doesn't go into 4, 4 times 2, 8, 3 doesn't go into 8, but 4 times 3 is 12, 3 does go into 12, my least common denominator is 12. I think most people wouldn't have a hard time with that. Okay, so now we're going to rename our fractions. We're changing the denominators. We've got to change the numerators as well. So I take the original denominator, the 4, and divide it into 12. That gives me 3. I take the 3 and multiply it by the numerator. 3 times 3x is 9x. The first fraction becomes 9x over 12. We do the same thing with our second denominator, the fraction. 3 into 12 gives me 4. 4 times 7x is 28x. And now what I have to do is a 9x minus a 28x, which is negative 19x. And we put it over the common denominator. Don't forget to put it over that common denominator. Again, once you have a common denominator, you really just working with the numerators. 9 minus 28 is negative 19, so that's negative 19x over 12. This can't be reduced, that's my answer. I want to do one more, and then I think we're gonna call it a day and then we'll continue with adding and subtracting a fraction on Monday. Again, don't forget, you're supposed to be doing your midterm this weekend. You have through Monday, the whole day Monday. So let's see, I have 5/8x minus 3x over 6x. Those I gave you these two fractions to combine. Okay, the first thing we're going to have to do is find that least common denominator. And since the denominators here, these are a little bit harder because not only do they have numbers, they also have variables. They are algebraic expressions. So here's what you do. First of all, these denominators, we're only dealing right now with denominators that are single terms, monomials. On Monday, we're going to talk about what happens if we have polynomials in our denominator. But now we just have single terms. What we do is we separately find the common denominator between the numbers and then between the letters. Now, between 8 and 6, we did that before. We had 8 and 6, that was 24. And 8 and 6 divide evenly into 24. So that's the common denominator of the coefficients, of the numbers. But what about the letters? We have to also include the letters. So here the letters are easier to deal with. Just pick the higher exponents because x will divide into x squared. Every lower exponent divides evenly into a higher exponent. So all you have to do is look at all the exponents in your denominators and just pick the highest one. Remember, we're not looking for a common factor, we're looking for a common denominator. So I can get something that both of them go into. So x squared is going to be the variable that we're going to use as our common denominator. So my common denominator becomes 24x squared. So we do the numbers the way we did the numbers before, the variables by picking the highest exponent. Then we rename our fractions. So in order to do that, I have to divide the original denominator into the new denominator, into the LCD. So 8 goes into 24 3 times, and x goes into x squared x times. I divided the 8x into the 24x squared. I got 3x. I take that 3x and multiply it by the numerator 5, and that gives me 15x. I then do the same thing with my second fraction. 6 into 24 gives me 4. The x squared into the x squared cancels out. So all I have to multiply the numerator by is 4. 4 times 3x. is 12x. Now that I have a common denominator, I just combine the numerator, the 15x minus the 12x, which gives me 3x, and put it over the 24x squared. And now I'm going to try and reduce this. So again, I combine the like terms, 15x minus 12x is 3x. I put it over the common denominator. Notice the 3 can cancel into the 24. This will give me 8. And the x will cancel into the x squared. That'll give me x. Notice everything canceled out on the top, so I put a 1 there. My final answer is 1 over 8x. All right. I'm going to stop right here because I know some of you are anxious to get started on your midterm. I give you a few minutes to relax. And again, starting at 10 o'clock, you're going to see that midterm on Blackboard. Don't forget, you have to go to Blackboard. There'll be a section on the side that says midterm. You click on it and you can start taking your midterm. You get only one chance to take that midterm. And you have to do it all in one sitting. So make sure that you're giving yourself enough time. I think I even gave you a little bit extra time. Instead of just giving you an hour, I think I set it up for an hour and a quarter. Give yourself enough time that you can do it all at one sitting, because if you stop the test, it'll just submit it and that will be your grade. If you have any problem, if your internet goes down or something like that, email me. I will keep an eye on the emails. I'm not going to sit with the computer all the time, but I will periodically be checking my emails to see if anybody's running into problems. And if you do, I can reset it. The only thing is, I can only reset the whole test. I can't reset part of the test. So if you run into a problem and your computer closed down for some reason, and I know that it's happened to students before, so I know this does happen, then email me and I will reset it so that you can start the test from the beginning. But it will have to be from the beginning. You won't be able to go back to where you had been. Any questions? If there are no questions, then I'm going to close the session now. Good luck, everybody, on the midterm.